Hi all, we are going for the second topic of this chapter, that is Oster's experiment. Oster's experiment. That is our topic number 4.2. Okay. Yeah. So the purpose of this particular experiment is basically this experimental observation exactly showed that there is a magnetic field associated to a current carrying conductor. Okay, so we are going to have few experimental observations, briefing of experimental observation. So let us go for the very first one. So here I am going to have a magnetic needle. So you need to assume this is a magnetic needle. So here this is north and here this is south, and it's pivoted here. Okay, so I believe you are getting it. It's pivoted here, and above this I'm going to have a current carrying wire. So the position of this compass needle is below this current carrying conductor. So this current carrying conductor is connected to a battery through a key. So here this is A and here this is B. Clear? So let me change the polarity here. This is south and here this is north. Okay, so it's clear that the key is not closed, it's open. So this direction in which the north pole is pointing, there has to be the geographic north, and here this is south, and here this is east, and here this is west. Okay, so now I'm going to close the key. The key is closed, so obviously there will be a current flowing in this direction. Alright, so here what was observed was this north pole of the compass that was turned towards the west. See, it was turned towards the west. So the south, it will turn towards what? East. Okay, fine. So this is experiment number 1, experimental observation number 1. Let's go for the second one. Okay, here what I will do is, I will take this wire downward. Current carrying wire is taken towards the downward position. So here, this is what's going to happen over here is, see, south, north. Okay, so here is a cell, key is open now. This is A, it is B. It's clear, key is open. That means here this north, south, east and west. So what I am going to do is I am going to close the key. So obviously, as you know, there will be a current flowing in this way. Fine. So once the current was flowing in this direction, what was observed was, this north pole that was bent towards east, along the towards east direction. In the above case it was towards the west. See, it was went towards the west, but in this case here, the first experiment, we had this wire AB above this compass needle, and here in this case we are going to have this wire below the compass needle. Okay, the position has been changed and the current direction remains the same. You can see that the current direction remains the same only. I mean to say it's flowing from A to B. See, A to B, and here also A to B. That means towards the right, here also towards the right. So the difference is just because of the position of the battery, the two both the figures. So here, as I told, this north pole was turned towards east, and the south pole was turned towards west. It was turned towards west. There was experimental observation number 2. All right. And experimental observation number 3, Oster's experimental observation number 3. I'll explain what it was. Observation number 3. Okay, so here again I'm going to have a current carrying wire conductor across which the battery is connected. Okay, A, B. This time the current is going to flow as usual, like once the case closed, from A to B only. So here the compass needle, it's pivoted here, so we need to assume this is north and here this is south. So normally this compass needle has to be in this direction, but we already had a discussion in the above case, experimental observation number 1. This need to be bent towards which? Towards west, and here this has to be turned towards the east. Okay, it's exactly the same as that of observation number 1, but here what I'm going to do is that in observation number 3 followed by this one, what I will do is I will change the polarity of the battery. See, like this. Polarity is changed now. That means a key is missing, right? Is missing. So let me keep it open now. Here this is the magnetic compass, and here this is south, and here this is north. Okay, now I'm going to close the key. So as you know, the current will be flowing from B to A this time. Okay, the current is going to flow in this direction. So now what happened here, this time the north will turn towards east. Okay, and the south, it will turn towards west. The same thing as over here. So that was second observation. Okay, so the first observation, we had the current moving from A to B. The north pole was turned towards west, and the south pole was turned towards east. And the second one, what I did is I changed the position of the wire. Here the second one, the position of the wire is below the compass. Okay, there it was above the compass needle, and there the rotation was just to opposite to that of the first one. That is, the north was turned towards east and the south was turned towards west. And in the third one, what I am going to do is that the setup is that of observation number 1 only, but here after having the first setup, I will change the polarity of the cell. Will change the polarity of the cell. As a result of that, there will be a change in the direction of current flowing. Here it was flowing from A to B, alright, A to B, and here it is flowing from B to A. There, in the first case, the north was turned towards west and south was turned towards east. In this case, south is going to turn towards west and north is going to turn towards what? East. Okay. And the fourth experimental observation is fourth one. The fourth experimental observation was that no setup is same as that of first one. Compass needle, south, north, north, south, east, west. The alignment has to be like this, obviously. Now, once I close the key, as you all know, the current will flow from A to B. As that we discussed in the first case, this has to turn towards west, and here this has to turn towards east. And once we do plug off the key, it was observed that the north pole that could turn towards north, it will come back to its original position. The alignment will be same as that of the initial case. Okay, so these are 4 experimental observations of Oersted. Okay, the 4 experimental observations of Oersted. I repeat once again what it was basically about. See, initially the current carrying wire was kept above the needle. It was observed that the north was bending towards west and south was bending towards east. In the second one, the position of the current carrying wire was changed, then it was kept, that means it was kept below the compass needle. There, the bending of the north and south pole of the magnetic compass was reversed, that means there the north was bending towards east and the south was bending towards west. So the conclusion is that the direction of magnetic field above the current carrying wire and below the current carrying wire is different. Okay, like above the current carrying wire, because once this compass needle was getting turned in one particular direction, once it was kept above and once it was kept below the direction of spin that has been changed, that means obviously it's very clear the direction of magnetic field above the current carrying wire and below the current carrying wire is different. And second case, the third one, it says that once the direction of current is being changed, then there also the direction of magnetic field is also being changed. All right, and third one is that the last one, the fourth observation, it says that this magnetic field do exist. That means this magnetic field associated to this current carrying wire do exist till the current is flowing through this wire only. Once the key was plugged off, you could see that that compass needle that was getting aligned back to its original position. That means the magnetic field of the earth only. Fine. So this rotation, that means this rotation of this magnetic compass, that explains that obviously as you know this compass needle is supposed to get aligned itself in the same direction of magnetic field. So initially this compass needle that was getting aligned in the direction of Earth's magnetic field, but once we made current to flow through this wire AB, there was a new magnetic field associated with that other than the Earth's magnetic field, and the compass needle was forced to turn in the same direction of the new magnetic field that we have developed due to this current carrying wire. And as the direction of magnetic field was changing, whether it was changing the position of the compass needle or whether it was a change due to the direction of magnetic direction of current, the compass needle was making changes as per that. So that was basically Oster's experiment, and based on this experimental observation, we finally concluded that yes, there is a magnetic field associated to a current carrying conductor. Okay.